All right, so I wanted to just briefly mention some applications of these hyperbolic functions because it is kind of interesting how are they sort of used. And so you can imagine with me that you take, maybe you've got these two cliffs. I don't know, maybe these are sides of Lake Taneycomo and there's two cliffs on each side. And then you hang a cable from one side that goes to the other. It's going to hang. That was a pretty bad picture, but you sort of get the idea. You got a hanging cable. It would be more pointed in the middle, I think, than my picture could do. So this cable actually has the graph y equals c plus a times the cosh of x over a, and c and a are constants, and so as you control c and a, you can change how much the cable hangs and so on and so forth. So what's really interesting is this was actually used to model the St. Louis Arch. And so I can give you the precise values. So it turns out that you can set y equal to, let's see, I'm going to need a little space here, 211.49 minus 20.96 cosh of 0.032911765x. Woof. And the claim is that this will trace out the shape that the St. Louis Arch is based on. That actually kind of intrigues me. Let's switch over to my Mathematica app and let's see if we can get it to work real quick, if you can hang with me for just a moment. So I'm a little bit curious. Hopefully you are as well. I need to get down where I can make a new cell. Input cell. Okay, here we go. So let's just say plot. And our function is 211.49 minus 20.96 times cosh of, it knows what cosh is, 0.032911765 times, I can't get the times right, times x. And there we go. And I want to plot this for x. Let's do like from -4 to 4. I don't know if that'll be enough. I have no idea what's going to happen. I know this is supposed to be the formula, but I've never done it. Let's try it. Oh, there it is. There's the St. Louis Arch. How cool is that? So anyway, that's one cool application of these hyperbolic functions. Okay, I promise this will be the last video, so I should really wrap it up. But I did want to do a couple of quick examples with you just to help with the homework. So these should be relevant to you. So one, you might be asked to simplify the cosh of the natural log of 3. And so you say, okay, fine. So this is e to the normally x, but we're plugging in ln of 3 plus e to the minus ln of 3. All over 2. E to the ln of 3, that's just 3, right? These cancel, leaving you 3. You got to deal with this negative. You can either pull it inside the logarithm if you want to. That's what I'm going to do. I'm going to write this as 3 plus e to the ln of 3 to the minus 1 is 1 over 3, all over 2. And so you get 3 plus 1/3 over 2, which is reduces 10/6, or if you want 5/3. Another way you could do it, though, is pull this out, and you could have e to the ln of 3 all to the minus 1, and that would give you 3 to the minus 1 as well. So there are two perspectives there. Okay, so the next thing that I want to do is just a quick limit with you. Let's look at the limit as x goes to 0 from the left. Oh my goodness, of cotangent of x. Well, we know that this is the same thing as the limit as x goes to 0 from the left of the cosh of x over the cinch of x. So we know that as x goes to 0, we can scroll way back up and look at our graph of cosh. Cosh is going to 1. Cosh goes to 1. And as x goes to 0 from the left, so x is going to 0, it's on this side of 0, that means cinch is going to 0, but it's negative. So Cinch is on its way to 0, negative. Cosh is going to 1, and so the form here is 1 over 0, but it's a negative 0, if you will. And so this thing is just minus infinity. And then finally, my last example, and I promise I will end these videos. Thank you for your patience. The derivative of e to the tange of 5x. And so you know the derivative of e to the whatever is, again, e to the whatever. So we get that. Then I got to multiply by the derivative of the whatever. And so I spit out what the derivative of tange is sec squared of 5x times the derivative of 5x, which is a 5. And so there you go. If you wanted, you could clean this up and say 5 sec squared 5x times e to the tange of 5x, and that's it. All right, we're done. Go do the homework. Ciao.